Hi all, myself Selin M. Assistant Professor, Department of Computer Applications, MES College, Marampally.
Today I am going to take the topic linked list from the subject data structures. So what is a data structure? Data structure means the mathematical or logical arrangement of data in computer memory. The data structure can be linear or non-linear data structures. A linear data structure means the data will be arranged in some sequential order. Examples are arrays, linked list, stack, queue, etc. Whereas in the case of a nonlinear data structure, the data will not be arranged in some sequential order. It will be arranged in some hierarchical order. Examples are trees, graphs, tables, etc. So now we are going to deal with the topic linked list. So as we said, linked list is a linear data structure. So a linked list can be said as an ordered collection of finite homogeneous data elements called nodes where the linear order is maintained by means of links or pointers. The difference between an array and a linked list is that array is also a linear data structure, but the data are stored in consecutive memory location. An array is said to be a static data structure. That is, once the memory is allocated, it cannot be extended anymore. Whereas, in the case of a linked list, it allows us to store data dynamically and manage data efficiently. Each element in a linked list is termed as a node, and the adjacency between each element is maintained by means of links or pointers. So this is the basic structure of a node. A node consists of a data part as well as a link part. So the data part will store the data item, whereas the link part will store the address of the next element. So this is the basic structure of a linked list. So A, B, and C are the nodes, and header means it is a header is a special type of node in which the data part of the header node will be null value, and it will store the address of the first element of the linked list. So the header node will contain the address of the node A, and the link part of the node A will contain the address of the node B. Similarly, the link part of B contains the address of node C, and the link part of C will have null value. That is, it indicates the end of the linked list. So, there are different types of linked list. Linked list can be a single linked list, or a doubly linked list, or a circular linked list. So, so we are going to deal with single linked list. So a single linked list, or it can be said that simply a linked list, is a linear arrangement of nodes. Then there will be header node. That is, the header node will contain the address of the first node, and each element points to a successive nodes, and the last element has a null value in the link part. We have to deal with what are the various operations on the linked list. That is, traversing a linked list, inserting a node in a linked list, deleting a node from a linked list. So first one is traversing a linked list, that is traversing a single list. The algorithm that is traverse underscore SL. SL means a single linked list. So as we said, there will be header node. The header node, the link part of the header node will contains the address of the first node. So these are the algorithm steps. That is, there will be a pointer variable, that is PTR. The PTR is equal to header dot link, means the header, the link part of the header node will contains the address of the first node. So the address of the first node is assigned to the variable PTR. So second step is while PTR not equals null. That is, we are going to traverse the single linked list till the last node. So PTR is equal to null means it is an empty linked list. That is, header, the link part of the header contains null value means the linked list is empty. At that case, the PTR will have the null value. While PTR not equal to null means the single linked list is not empty. There is an element. So PTR is not equal to null. That is, in the first case, PTR will contain the address of the first element, then process the PTR. That means the process the first node. Then after processing the first element, PTR is equal to PTR dot link. That is, now PTR currently points to the first node, and the link part of the PTR will contains the address of the success element. So that is the address of the second element will be stored to the PTR. Now PTR points to the second element. Again, we will continue the while loop while PTR not equals null. That means that PTR contains an address of an element, that is a second node. And if it is not null, again process the second element. Suppose the third element, it contains only two nodes. That is, the link part of the second element will have the null value. In that case, PTR is equal to PTR link means the second, now PTR points to the second element. The link part of the second element will contain null value since this is the last node. Again comes to the while loop, while PTR not equals null. In this case, PTR will have the null value. So it will exit from the while loop, and thus the process ends. So this is how traversing a single linked list means. That is, we are traversing from the first element till the last element. The second operation is insertion of a node into a single linked list. So we can insert an element at the front of a single linked list. We can insert element at the end or as a last element, or we can insert element at any position. Okay, for inserting a new element, we create a new node or get a new node from the memory bank. So all the free nodes are stored in a memory bank, and we have here, this is a procedure for availing the get node. That is, avail is a pointer which points to the first element of the free memory bank. So if you want to insert a new element, first we have to call the procedure getNode. So if avail is equal to null, that means that it is an empty list. That is, it doesn't have any free memory. So it will return the null value and it will print that there is insufficient memory. Else, if avail is not equal to null, that means that there is a pointer variable PTR. PTR is equal to avail means it contains the address of the first node, free memory node, and we request for a node and we have the size of that node. So the while loop will check while size of PTR, that means size of the first free memory node, not equal to the size of the requested node, and PTR not equals null. That is, this while loop will continue till if we get the node of our requested size or till we reach the last node. So while size of PTR not equal to size of the node and PTR not equal to none, that is, it is not the end of the linked list, then we are using another pointer variable, that is PTR1 is equal to PTR. That is, current node's address will be stored in PTR1 and PTR points to the next node, that is PTR is equal to PTR link. Again we will check the second node, that is the size of the second node is equal to size of the requested node and not equal to size of the requested node, and PTR not equals null. Suppose the size of the requested node is 50 KB and the size of the current node, that is size of PTR, is also equal to 50 KB. That is, the second node size is equal to size of the requested node. In that case, it will exit from the while loop and it will come to the step number 4. That is, if size of the PTR is equal to size of the node, then what we have to do? We have to return that node to the calling process. So there is another pointer variable, that is PTR1. It will point to the previous node. So PTR1 link, that is a node that we have requested, is a PTR node, and PTR1 points to the node that is the previous node of the previous node. So PTR1 link part will contain, at present PTR1 link part will contain the address of the current node, that is our requested node. Now if we got the if we have to return the current node to the calling process. So PTR1 link part should contains the address of the node that is success next to the requested node. So PTR link will contains the address of the next node, and that address have to be stored in PTR1.link, and we have to return the PTR, that is the 50 KB size node should be returned to the calling process. That is how it takes place in step number 4. There are two conditions for exiting from the while loop. That is, first condition is that we have discussed, that is the size of the requested node is equal to the size of the current node, and Another condition is ptr is equal to null. That is, till we reach the last node, we didn't find a node having the requested size. In that case, you will come to the step number 5, that is else print the memory block is too large to fit. Okay, so that is how this get node function work. An element at the front of a existing list, then the new node link part should have the address of the header link. That is, the header link will have the address of the current first node. So that address should be stored in the link part of the new node. That is, new.link is equal to header.link. Okay, then new dot data, that is the data part of the new dot, will store the data that we have to insert. That is, suppose it is x, and then the connection is established between a new node and the current node. Then we have to establish a connection between the header node and the new node. That should be done by header dot link is equal to new. Okay, that is how from these 3 steps we can insert a node at the front of a single linked list.